Hello, folks. This is activity TY03, and you have done a problem similar to this, or actually, I did it on the in the class for you, where a single block was supposed to go on a around a track, basically, and there I essentially did the problem using 2 point curve joints. Okay. Now here, that approach doesn't work, or let me put it this way, it can work, but I'm not going to do it like that. So I have a cylinder here, which is supposed to travel along that path. So the path just happens to be that circle. So let me go ahead actually and do the problem and show you what's going to happen when you run into a problem and you've got to fix it somehow. Dimensions are not important. That's entirely up to you. So we go here. I'm in part design. Immediately I save. So file, save management, save as, my desktop, new folder. And this is going to be February 25, 2024. Okay, so everything is going to go there. All right, I'm going to insert my first part, which is going to be that base. So insert a new part in there, and I'm going to call this thing the base. Right click properties, base, and base. Okay, and let's go make it. Again, ignoring dimensions. On that plane, I will sketch a circle. Exit and pad. I'll pad it in the other direction so that I can put the cylinder immediately on the top, reverse direction. It really doesn't matter. Now, for a reason that it becomes clear to you later on, I will create a point on this cylinder. So, for example, a point right at the center of that. It doesn't have to be the center, but I'll make it the center for sure. I have a point here, and yeah, that's pretty much it. So I did create a point here, which happens to be in the base, and it just happened to be at the center. All right, so we go all the way to the top, click on the floppy, so everything is going to go into that folder. Watch out for these things on your test. So insert a new part in there, and I'm going to say cylinder. Properties cylinder, a moving cylinder basically, and cylinder. Say okay, and I'm going to make it. Double click. All right. Uh, let's see. On that same plane, for convenience, I'm going to sketch a little circle. It's going to get padded in a minute. Let me make this thing a little bit bigger. Exit, pad it. That's fine. Let me make this thing taller. Maybe 40 millimeters so that it looks nicer. All right, good, good. Now, I'll do two things. We'll create a point at the bottom of this, the center of it, because eventually I want to put the center on that track, okay? And then I'm going to also create a point on the top. You might say, why do you need the point on the top? You'll see it in a minute. So let me do a point, circle center, down here, and another one, same story, circle center, up there. So I have this point and that point in the cylinder, and this point in the base. Now, this bottom point is going to be used to place it on that track. And you might wonder, why do we need that top point? Or why did we ever need this point in the cylinder? in the base, you'll see that in a minute. So all the way to the top, save everything. Okay, now we're going to do assembly, our assembly constraints. So first of all, let's fix the base, right there. And then I want to put this point on that curve. Okay, so we say coincidence between this point and that curve. Now, the only thing is that you notice that I cannot actually pick that curve. So what right there, actually. I'm not sure. No, Control Z. Okay. So let me show you one more time. This coincidence between this point, and I try to select this boundary, but the problem is that as soon as you select this thing, the whole the axis of the disk is going to be selected. So you see that? I don't want that. Cancel. So here's what I'm going to do. Control Z. What I'm going to do is to go back to the base and create a point on that edge. Okay? So back to the base, a point on a curve. And what curve? This curve. Doesn't matter where. The answer is no. Not on the plane, on a curve, on that curve. Oh, there's a problem here, and you can see that when I say the curve, now it's better. Okay, good. So you have to fool around with it so that you can select the curve as opposed to the face. Now, there are ways to filter this out, so I'm not going to bother about it right there. So notice that a point has been created there, and I can put this point coincident with that. I could not do it with the way it was. There are ways to fix, of course, with that edge, but anyway, so let's go ahead and do that. Back to the assembly design, constraint between this point and that point, and update, and there we are. Now, remember, I padded this thing to the bottom because I didn't want to bring this thing and put it on the top. I could have if I wanted to, but I'll just leave it the way it is. Now, that's pretty much it. So I will come back. I will have to come back in this part and do something, in this cylinder and do something. But let's not worry about it right now. Okay, we go all the way to the top. Let's go to the digital markup, DMU kinematics, get the magic wand out, and new mechanism, auto create, and we say okay. So let's see what kind of joints were actually created here. Spherical. And why did it become spherical? Because I made a point and point coincidence. That's a spherical point. So I don't want this thing. Let's delete this. Let's not delete the children. Good. So I want this point to be on that curve. So what is that? That's a point curve joint. Point curve joint. So the curve is this, and the point is that. Now, if you cannot pick it, you can either, because this is blocking it, you can either, the 2 points on top of each other, right? So if you're having problem, right click, hide it, and you can pick it. Because there were 2 points on top of each other, obviously you could not have picked the point that was from the cylinder because that does not make a joint. Or I could have taken it from the tree. Say, okay. Now, the other thing is that the bottom of this should always stay on the top of the cylinder. So that's a planar joint. So here's a planar joint between the top of the cylinder, the top of the base and bottom of the cylinder. And notice that we do get a degree of freedom reduced, and now degree of freedom is 2. Okay, so what do we do? Let's make this thing angle driven. Length driven. So you can see it's moving. but there's an extra degree of freedom that is left. And if I try to go to planar joint, it doesn't have any command associated with it. So what happens? What happens is that this cylinder can not only travel along this path, but it can also spin about its own axis. That's why we have an extra degree of freedom that's left over. So here's the trick that I'm going to do. I am going to create a plane between in the cylinder. I'm going to create a plane in the cylinder which passes through the top point, the bottom point, and the point that I created at the center of the base. You might say, why do you need that? Just be patient, you see it. So go back to the cylinder, create a plane. Here's the plane reference element. And the method of making it is going to be from about 3 points. And what are the 3 points? There is going to be the top point. There is going to be the bottom point of the cylinder. See that? Pick these two. And I'm going to select the point that I created at the center of the base. So this plane that I created actually passes through that center point. That's good. Because when I go back to digital markup, I can create a joint called point surface joint. So a point always stays on a surface. Okay? And what do I want? I want this point at the center of the cylinder always stay on this plane that I created. Now, I use a plane, but it could have been a surface. I could have created a surface here if needed, okay? So here's point surface joint. Surface is going to be that plane that I just created in the cylinder, and the point is going to be that point at the center. In order to create a point surface joint, the point must be on the surface. This is why when I created the plane, I made sure that this point at the center of the base was actually in this plane that I created in the cylinder. And I say, okay, when I do that, it becomes degree of freedom equal to 0. Mechanism can be simulated. And now let's go ahead and do that manually. You see, this is going to turn, but it's not going to spin. It is not spinning about its own axis. So we didn't run into this issue because when we did a block, we made 2 point curve joints, and that took care of that spinning. You'll never spin. Now, you could have tricked this thing so that, there are 2 points. There are 2 points that are exactly staying on that boundary, etc., and done the problem. But anyway, this is the story. Good luck.